Hello and welcome students to a new short class in AS level chemistry. The reaction that I'm going to discuss is the reaction between an alcohol and SOCL2, which is called sulfur dichloride oxide. It is sometimes also called as thionyl chloride. And this is used to convert an alcohol into a chloroalkane in this way, and these are the products which you are told to remember. For example, if you take the reaction like CH3 CH2OH plus SOCl2, it's going to give you CH3 CH2Cl plus SO2 plus HCl. So effectively what happens in this reaction is that the OH group gets replaced by the Cl group, and SOCl2 therefore is the chlorinating agent. One problem with this reaction is that it's difficult to remember that these are the three products starting from SOCl2. In order to make it simplified and so that you can understand and remember the products form, you can split the SOCl2 in this way, and that will help you to remember the reaction. Write SOCl2 as SO, a Cl here and a Cl here, and then combine this H with Cl to form HCl, combine this SO with this O to form SO2, and then it's very easy to remember that the products are CH3 CH2 Cl plus SO2 plus HCl. So this will do the trick to remember that besides CH3 CH2 Cl, the other two products are SO2 and HCl. And these two products, being gaseous in nature, escape very easily, which helps the reaction to be carried in the forward direction. And therefore this is one of the good ways of converting alcohols to chloroalkanes. Now I have told you in one of the videos that this reaction doesn't really work. And the reason that I have told you is that the OH minus is a strong base and therefore a bad leaving group. In fact, the function of SOCl2 is that it converts the OH minus, which is a bad leaving group, to a good leaving group, and this is what I'm going to show you just now. What really happens is that this ROH combines with this SOCl2. This lone pair of electrons attacks this sulfur and it enables the chlorine to go out. So what you get is and now you can see that this oxygen has a positive charge, and therefore this becomes a very good leaving group, because this oxygen being positive and also attached to chlorine, which are strongly electronegative, this electron pair can be pulled away by the positive oxygen, and this can go out as a good leaving group. So the Cl minus can attack on this carbon, on the carbon of the R, and enable this whole thing to go out as a good leaving group. So this becomes RCl plus OH SOCl. And finally, this electron movement takes place like this, and it gets converted into SO2 and HCl. So this helps you to understand that how SOCl2 is effectively used to convert OH minus, which is a bad leaving group, into a very good leaving group, and that enables the OH to be easily replaced by the Cl. So this is a simple explanation to why effectively we use SOCl2 to replace OH by Cl, even though this explanation is not included in the syllabus of the AS level chemistry. But for the students who are curious, this will help them to understand how and why do we use SOCl2 and also PCl3 and PCl5 to replace the OH by the Cl. The explanation remains the same, that OH minus a bad leaving group is converted into good leaving groups, and therefore the alcohols can be changed to chloroalkanes. Thanks a lot.